Hello, so in this video, I want to look at proving a result named as the product rule. So this is the product rule here. So again, it's another one of these rules similar to the chain rule that we can use in differentiation to find derivatives of more complicated functions. So the product rule states this. So it states that if we want to find the derivative of f of x multiplied with g of x, all with respect to x. So this is the derivative of f with respect to x multiplied by g of x plus the derivative of g of x with respect to x multiplied by f of x. So this is the product rule. And it's just like a brief example up here. So if we wanted to differentiate something like x times sine x, so the rule states that if we, we've got two functions here, x and sine of x, and they're multiplied by each other. So this is when we can use the product rule. So if we differentiate the f, so we call this the f there, this first function, and we'll call this sine of xg. So using the product rule formula, we're going to differentiate the f first. So differentiate the x gives us 1, and we're going to times that by g, which is the sine of x up there. And then we're going to add the derivative of g. So the derivative of sine of x, so we know now that's cos of x. And we're going to multiply that by the f, so that our f in this case is the x. So we're going to multiply that by x. And as a final answer, we'll get sine of x plus x times cos of x. So that's the derivative of x sine of x using this product rule. But what we're going to do in this video is we want to prove that this product rule is true. And to do this proof, we're going to use our standard definition of differentiation using limits. So we want to find the derivative of f of x multiplied by g of x. And again, using our standard definition. So this is the limit as h goes to 0 of, so usually it would be f of x plus h, subtract f of x all by h. But because we got the product of two functions, what we're going to do this time is do f of x plus h, and now multiply that by g of x plus h, because we got the product of these two functions. And similarly with the second bit of the numerator, so we're going to subtract f of x multiplied by g of x, because again, we want to differentiate the product of these two functions. And again, this is all divided by h. So we've got this step there. Now, what we need to do to kind of prove the product rule is we just need to do a little trick with this numerator. So what we're going to do is, again, we're just going to write limit as h goes to 0. And then the trick is, so if I just copy out what we've already got, subtract f of x, g of x. So the trick is that we're going to add a term and take away that term. So we're just basically adding 0. But we're going to add these two terms in. So we're going to add g of x plus h times by f of x. And then we've got to subtract that, because we don't want to add any new numbers to the term, because otherwise that changes the fraction. We don't want to change the fraction. So we're going to add this term and then take it away, so that we don't affect our original fraction. And again, this is all divided by h. Okay, great. So now what we're going to do with this numerator is we're just going to do some factorizing. So what I'm going to do is I'm going to look at this term here, this first term, and I'm going to look at this second term there. So both of these terms share a g of x plus h here. So what I'm going to do is just factor out the g of x plus h. So we've got limit as h goes to 0. Then I'm going to factor out this g of x plus h, which means we're going to get an f of x plus h here, and then a minus f of x over there. So that's the first bit dealt with. And then I'm going to factor out I'm going to factor out this f of x and this f of x from these two middle terms. And if we do that, we're going to get a plus f of x, and then factoring out these two terms there. So the g of x plus h, but a positive g of x plus h, and we've got a negative sign there, so we're going to do a negative g of x. And that's the top bit dealt with. This is all over h. Okay, so what we can now do, because taking a limit is it's a linear operator, we can just split the limit into two different fractions. So you've got the limit as h goes to 0 of g of x plus h multiplied by this f of x plus h, subtract f of x, and this is all divided by h, and then plus the limit as h goes to 0 of f of x multiplied by this g of x plus h, subtract g of x, all divided by h. Okay, cool. So if we just look at this first limit on the left side there. So as h goes to 0, well, this h inside the g function, that's just going to go to 0, and then we're going to get a g of x for this bit there. And then if you notice, so if we take a limit of this fraction over here, well, that's just literally the definition of f of x. Sorry, the definition of the derivative of f of x. If we remember, f of x is defined as, sorry, the derivative of f of x is defined as the limit as h goes to 0 of f of x plus h subtract f of x all over h. And so this here, this fraction over here, is going to tend to the derivative of f of x as h tends to 0. And a similar kind of thing is going on over on this side. So as h goes to 0, f of x just stays the same. So that's just the same there. And then this g of x plus h subtract g of x all over h. Well, that's going to tend to the derivative of g, because again, by definition, the derivative of g of x is the limit as h goes to 0 of g of x plus h, so that bit there, subtract g of x over h. So again, what we're going to get just by looking at these limits and simplifying the whole thing is we're going to get a final result of g of x multiplied by the derivative of f plus, again, if we go back, we're just going to keep the f of x there because we've got no h's involved, and that's multiplied by the derivative of g of x. And so this is literally the same as saying g of x multiplied by the derivative of f with respect to x, and then plus f multiplied by the derivative of g with respect to x. If we go back to the first slide, this is what we had here, exactly the same thing. And so this proves the product rule. And so therefore, when we differentiate the product of two functions, we get the derivative of f with respect to x times g plus the derivative of g with respect to x times by f.